Hello, so today we're looking at question 739, daily temperatures. Given an array of temperatures, daily temperatures, we want to return an array answer such that answer I at index I is the number of days you have to wait after the ith day to get a warmer temperature. If there's no future day for which this is possible, just place 0 in that index position. So let us look at an example here. Oh, whoops. Sorry about that. 73, 73, 74, 75, 71, 69, 72. It's a really long first example. Sorry about that. Okay, I think we got it, right? This is a 3. Okay. All right. So given this array of temperatures, we want to make sure that what we return is how long we'll have to wait for the next greater temperature day. So the resultant array will be something like, because you only have to wait 1 day for a warmer temperature, you go 1 day, again 1 day for a warmer temperature, you go 1 day. This one 75, a warmer temperature, you have to wait 1, 2, 3, 4 days. So 4, 71, you have to wait 1, 2 days. This one we have to wait how many? Just 1 day. Again, 1 day. 76, we wait 0 days and 0. Let's just double check our answer. Okay, looks correct. So how do we come up with this array, right? The key to solving this problem is we have to use a monotonic stack. So it's kind of like the stack's function is basically to keep a record of the indexes that have not been updated yet, like the positions that have not been updated yet. And once we have an answer to it, we kind of pop things off the stack and write it onto our array. So that might sound a little cryptic. Let's start by drawing some diagrams to illustrate this. So I have a temporary stack. What I want to do is, firstly, we need to go down the temps array to process each element one by one, right? So first off, my stack is empty, right? What I can do is I can only insert this 0 onto the stack, push this index 0 onto the stack. Remember, index 0 signifies this 73, so keep that in mind. Now, once we do that, we move on to the next element, 74, right? Remember that we want our stack to have elements, indexes of elements that are strictly decreasing. Why is it strictly decreasing? It's because if it's increasing, we already know the answer. We can already pop this last topmost element of the stack, and then we can write it onto our resultant array already. So we do not need to keep it on the stack. So as a result, all our elements on this stack needs to be strictly decreasing from bottom up. So it has any numbers above like this 73, for example, it has to be less than it. If it's more, like 74, what we do is we pop it off the stack. So now we're looking at 74. 74 compared to 73, it is 1 more. So what we do is we pop it off the stack. And because we are at index position 1 right now, we can directly calculate the difference between index 1 and index 0, and then we write 1 to the resultant array. Okay, now we have this. Now, at the end of this turn, we push 74, we push the index of 74 onto the stack, right? I'm gonna run out of space. What should I do? Okay, I guess it's fine. Let me just continue now first. I'm sorry. 74, right? Again, now at this point in time, we've moved on to 75. So comparing 75 with 74, we can see that 75 is bigger than 74. So again, we pop this off the stack and we write the difference between the indexes on in our resultant array. Okay, moving on, right? Next one. We now have push index 2 onto our stack, and this corresponds to value 75. We compare 71 with 75. Okay, let me just copy this here and pray that it's enough space. Okay, so now we have this 2 on our stack, right? It corresponds to the value 75. We can see that 71 is actually less than 75. So we can happily push the index onto our stack now. Now looking at 69, and we write, because we have to put a value to it first and then we move on, right? So we just push 0 onto the stack first. Again, this will be 0 first. We'll come back and we will revisit these values, don't worry. So okay, now we're looking at 69. 4, right? 69 is also less than 71, so we can push it onto the stack, right? And once we end this turn, we add 0 to it. Okay, now we finally reach 72, right? 72, we can see that it is, well, more than 69. So remember what we said we'll do? We will pop this off the stack, and then we compare the difference at index 0, 1, 2, 3, 4, 5, and 4. So it's a difference of 1. So we need to write at position for index 4 the difference between the current index and it's the one on the stack, which is 4. And then we compare the next element, which is 71. 71 compared to 72. Again, it is 72 is more than 71. We cannot push it onto the stack, right? So we also strike this off. And because the difference between 5 and 3 is 2, we go back at position index 3, and then we overwrite the correct value. Now we look at 75 and compared to 72. 75 is greater than 72, right? So what we want to do is push it onto the stack. 5, it is this corresponds to 72, and we move on to the next element. And don't forget to write a 0. Okay, 76. 76 compared to 72. Oh, finally, we have 176 is greater than... Wait, hang on. No. Okay, so 76 is greater than 72. We cannot push it onto the stack. What we want to do is basically pop it off and then take the difference between index 6, current index 6, and the topmost index on our stack, 5, a difference of 1, so we'll override it here. And then don't forget there's still one more element on the stack, which is 75. 76 is greater than 75, right? So we can now finally pop off this 75 off the stack, and it's at index 2. So because 76 currently the element we're looking at, 76, is at index 6, right? 0, 1, 2, 3, 4, 5, 6. So the difference between 6 and 2 is 4, right? Yeah. So there we have it. Now we can continue doing it for the rest of the array, and we will find that it's gonna be 0 and 0 when we end it. So let's move on to the code. Yes. Okay. So first we need a temporary stack. Okay, once we have that, what's next? Okay. All right. So we need to loop through our temperatures array, right? For index and temp in enumerate temperatures. What we want to do is while we need, let's write the condition of checking if there's elements in the stack, and then deciding if we want to push onto the stack, or deciding if we want to pop off the stack or not, because this condition will, we have to write this condition first before we keep pushing onto the stack. Because imagine if we push, remember we say that we want our stack to be strictly decreasing from bottom up, right? So imagine if we just push it first before we write the while loop, the while condition to get rid of to pop the stuff off, we will risk the situation where maybe we push a greater value onto the stack first, greater value compared to the top of the stack, previous top of the stack. I hope I'm making sense. Anyway, so let's write the while loop. While stack, well, there's something on the stack, and we want to check the top temperatures, temp stack. This should be temp stack -1, which is the top element, is, okay, we want to make sure that the top element, whichever top element it is less than our current temperature, temp. Then we want to do a popping index, popped index equals to temp stack pop. This is the index that we popped off, and we want to write to our resultant array. Oh, I need to have a resultant array first. Res at index popped index is equals to the difference of I minus popped index. Okay, and then remember we have to push. If the while conditions are not fulfilled, we want to push onto our stack, temp stack, and our current index. Also, remember we want to just push a 0 first. Okay, return res array. Oh, wait, what? Okay, res array. Okay. Okay, alright. Thank you for watching this video.